Hi class, welcome to lesson 22. In this lesson, we'll continue our exploration of how the model of the atom changed over time. We're 2/3 of the way done. In addition to describing the major subatomic particles, we are going to delve deeper into Rutherford's gold foil experiment and see how his experimental outcomes led to the nuclear model of the atom. The model of the atom with a nucleus. Again, we will reinforce how we read isotope symbols to determine the number of protons, neutrons, and electrons in a species. Make sure you are taking notes as you follow along. Recall that this is part 2 of a 3-part series where we are exploring the big idea that the modern model of the atom evolved over a long period of time through the work of many scientists. In lesson 21, we ended with Thomson's plum pudding model. Thomson understood that atoms were neutrally charged because they are not attracted or repelled to other atoms. But he believed that this neutrally charged particle had negative pieces, which we now call electrons. And these electrons were embedded in a diffuse positive goo. Rutherford was a scientist who set up the gold foil experiment. It involved gold foil, a very thin sheet of gold assumed to be only 1, 2, or 3 atoms thick, and alpha particles. Alpha particles are positive particles that radiate from the nuclei of radioactive elements. As Rutherford shot alpha particles at gold foil, he observed that most of the alpha particles went straight through the foil, but some were deflected. He had the first model that suggests the existence of a small, dense, positive nucleus. Here you can see what Rutherford expected to see in his experiment. As the radioactive element on the left released its alpha particles toward the gold foil, he expected the positive alpha particles to simply move straight through the foil, because the foil's atoms were believed to have a diffuse cloud-like positive region and no distinct positive parts. Again, look here at Thomson's model of the atom. You can see the negative electrons, but the green part is just this positive cloud. He assumes that the positive alpha particles will not be repelled or attracted to the positive particles, but instead will move through, much like a beam of light can move through a cloud. Because Rutherford thought that Thomson's model was correct and that there were no distinct positive particles, he believed that the positive alpha particle would simply go through the diffuse, cloud-like positive region of the atom. Here's one more look at what Thomson believed was going to happen, because again, that positive massive goo was very diffuse. He thought the alpha particles would go straight through. But of course, this is not what Rutherford observed, and instead, he saw that most of the particles went through the foil. Some were deflected at small angles, while other particles bounced back with great force. He needed to come up with a new model to explain his observations. So first, Rutherford observed that most of the particles went straight through the foil. This had him conclude that the atom was mostly empty space. Then he noticed that some of the particles were deflected. This led him to believe that the positive alpha particles were deflected by a positive center of the atom. And finally, Rutherford observed that some of the alpha particles bounced back like they hit something, so he determined that the center was not only positive charge, but it was very massive or dense. So here is another summary of Rutherford's findings. It is very important that you are able to explain how this experiment worked, what observations were made, and how each observation led to a new model of the atom. When the particles were deflected or bounced back, that led Rutherford to believe that the nucleus had a small, dense, positive nucleus. Since most of the particles did go through, he determined the atom was mostly empty space. So if Thomson's model was correct, all of the alpha particles would have gone through the atom. Rutherford revised Thomson's model to include a nucleus in the center. This explained why most of the particles were actually able to go through the atom because it was mostly empty space. But some of the particles were deflected at a small angle because the positive alpha particles were repelled by the positive nucleus. And those particles that bounced back must have hit the small, dense, positive nucleus. That concludes lesson number 22. We will look at the last two models of the atom, the Bohr atom and the quantum mechanical model of the atom, in lesson number 23. Stay positive like a proton, and I'll see you in class.